I'm very pleased to be here with Qetu from the Analog Computing Meets Modular Synthesizers booth here in Superbooth 2025. And well, I think you have a very interesting thing to tell us, Qetu. So why don't you present yourself and tell us a little bit what you have today here?
Yeah, I'm coming here, I'm showing off how to integrate analog computing ideas and products into your modular synthesis. I brought with me on the one hand an old analog or old-fashioned style analog computer and a rack which we can see here, where I have included typical simple modules that do easy analog operations. For example, we can see here a precision adder that can just add voltages. We see modules that can switch between different signals, or that can multiply signals, or we have integrator modules that can do integration.
And why you take this approach about analog computing with modular synthesizers? What is your inspiration for that?
Definitely not to save on space or money, but because you won't.
Yeah.
But for me, to get a better understanding, because from these easy building blocks you can build, I can't say everything, but any simple modular module you may imagine. And because I do not come originally from the Eurorack, but from an analog computer. So my first thinking was in the building blocks of an analog computer. So when I came to Eurorack, I started with analog modules anyway, and after some time I got the idea, why not find analog modules that do the same thing as my building blocks on an analog computer.
Okay, that's very interesting. So you will say it's a mix of science and cables and machine and different stuff that you are also interested in.
Science is maybe a bit too much. Let's say it's in German we have the word Klangforschung, maybe like sound exploration. Something like that. Because I have no electronics background, I have no musical background. I'm just more or less just playing around and trying to build stuff and trying to understand how some principles work.
Okay. What would be like the hello world if you were like doing like a very basic patching, like that in music, in synthesizers you have the subtractive synthesis voice topology, which is like the basic building block for a typical voice. What will be the basic or the most basic stuff you could build with a system like this?
The most basic stuff you could use is at least have, I would say, one of each elementary building blocks. Like you would need one integrator, one summer, one comparator, and one multiplier. With this very minimal setup, you could already build, for example, a triangle core oscillator.
Okay.
Yeah, it was one of my hopes why I'm showing this idea around here and there is I hope some capable module maker might catch the idea. And I would like to be the first customer to get a Eurorack module where you could have this one, maybe this size, one module that would offer each of these base functions.
Okay.
Then the customer, if he bought one module, he could do elementary patches already. But if you buy a second or even a third one, you could buy more complex stuff. With two modules, you could buy, for example, a quadrature sine oscillator. With three modules, you could already build some complex things like chaos oscillation. So my dream would be to have this inside the Eurorack, but not as such as it is now, like a bit collection of different modules, but as a certain computing module side by side.
Basic math computing building blocks.
I mean, the math module is a good example. The math module is based on the DUSG from Search. They already provide some basic musical sorts because you are generating slopes, and slopes are already an important ingredient. And with the Mars module, you can do a lot of things. I'm not sure if you can do any analog computing task with the Mars module. So with these things, I would say it should be possible to even rebuild a Mars module. Although I tried that and I only succeeded halfway up to now. But this is of course definitely a good comparison.
Yeah.
I would say that my approach is even one level below Mars, because the elements I'm using are not even thought to do musical stuff in the beginning.
Okay.
You could, for example, to get sloops.
And they don't produce sound by themselves. You need to patch them.
Exactly.
You need to patch them.
There's no sound out right away. You have to do at least a simple patch to do so. But for example, if you have two integrators and an inverter, this will already give you a quadrature sine.
Okay.
So you can get an oscillator quite simply.
Okay.
With
Yeah. I saw
elements.
that you make like a VCO with integrators, and when you were patching and on the diagram you show on your Schneider's Laden talk, I remember that pretty much everything is always like in a feedback loop.
Yeah, exactly.
So why is that the feedback is what is actually creating that movement in time? Or
feedback is the core element if you want to do anything in analog. I mean, of course, if you're using an oscillator, you don't need to make any feedback to get a sound, because it is already done for you. But if you look inside an oscillator patch, you will see that it will always contain feedback, as the same as a filter or so. From an analog computing perspective, I would say, because analog computers work that way. Because if you want an analog computer to output anything that's lasting over time, that's not just a quick click or so, then you need to repeat things. You need to send things back into the input. So without feedback, I can't imagine any sonically useful events.
Okay.
This is also why an integrator is the most important element of them all.
Like the basic, like the core of the analog computing. Yeah, right.
Exactly, because an integrator is the only function of the ones I mentioned that's in the time domain.
Yeah.
It stretches things over time. It slows things down. It's taking care of that thing has a duration. And without an integrator, so everything you patch would just happen in an instant. And that would not make sense, at least not for me.
I remember that this integrator model is very nice, a very nice integrator from Ladik, and he also has like a derivator model. But this derivator, I think, is different approach. It's not doesn't have a slews, no, right?
It's mathematically it's the opposite. I've heard from analog computing that integrators introduce less noise. I cannot say anything about the Ladik module there. I did not try them out, but I heard that the integration way is a bit more precise and less noisy. But I have no proof for this. Further than that.
So yeah, that's why they are built like that, and when you are solving a problem with an analog computer, you prefer to use integrators as other tools.
I have not seen yet an analog computer that would have derivators. They seem to always have integrators.
It's possible to build like you say. It's possible to build a VCO, a triangle core, and stuff like that. But it's possible to build like a filter.
Yeah. Also, it's the easiest way to build a filter is just to use one integrator and to patch, to give a little controllable feedback patch.
And that's it.
That's it already.
That would be but a low-pass filter.
Because by the amount of feedback you give into the integrator, you soften the hard edges in a signal. If a signal is frequently changing, it will have many hard edges. And if you send it through an integrator and feed it back to itself, then you will just soften the how much it can change over time.
Okay.
Yeah, this would give you a low pass filter.
Yeah, And then for a high pass, you will need to subtract from the original signal probably or something like this.
It's not much more complicated. I looked into some schematics for analog computing high-pass filters. It's 1 or 2 steps more, but I did not really try it out.
Okay.
My first tries have been so far a triangle core oscillator, which has also through zero capabilities, and a sine oscillator and chaotic oscillator. These are the patches I tried out. Okay, sine oscillator is as such is of course too simple, but you can easily use it to modulate other signals, for example.
If someone is interested in this, what would you suggest to them? How to start, to learn, to watch some videos, to read something? What would you say is the best way for start? If you have to give advice to yourself again or from the past?
Yeah, maybe my entry was by buying an analog computer, but maybe that's one possible step.
Yeah.
But let's say you come from Eurorack, I would say get at least each of the basic functions I mentioned. That would be an integrator, some kind of multiplier, precision adder, some inverter, and
a switch. The switch are very useful also.
Yeah.
I think.
Exactly, they are useful for many things. I mean, they have a reason they are already there. They have not been built to give people analog computing capabilities. All these modules can be used, of course, in your patches anyway. But if you have each of them, you could start building, for example, a triangle core oscillator already. And then look where this takes you and where you might go from there. And yes, I mean, I don't want to recommend any specific vendor. In the case of the integrators, I only found one, but yes, precision adders should do fine. One important thing is that you have to take care that all the modules need to deal with DC.
Okay, DC couple.
Because exactly.
Obviously,
because
then
your signals might be intentionally slow or even steady.
Of course.
And if the module
DC couple is very important.
You're lost.
It's very important.
For example, I bought a Döpfer ring modulator, thinking that would be a multiplier, but it can't deal with DC. So it's for my purposes, it was completely useless. On the other hand, the dual polarizer from Döpfer did the trick. This can be used as a multiplier.
Okay. I also think, I see some logic module here. But I have also read sometimes about analog logic. There's analog Boolean. There's Boolean logic and analog logic.
Let's start with this module. This module is a bit a red herring. This is not this. While this is very useful as such, this is not analog computing because this is gate logic. This is operating in imaginations of high and low signals. High and high is high, high and low is low, etc. We are always. It's like 1 and 0. This is digital logic. But you can, of course, you can make use of this. One very easy usage for me is I have voltage sources here. The inverters always give fixed voltages, and I can use them at any other place. But of course, anything else like 3 times Mia would also do the same purpose. But you can, of course, it's not forbidden to combine these things. Why not combine gate logic with analog computing? But this is not a core idea of that.
No. But I was this is very interesting what you're saying. But what I was referring is that there are some modules that are prepared for doing like analog logic. Do you know?
I think what you mean are some maximum or minimum functions.
Yes,
exactly. Yeah, this is, of course, you can define, for example, a minimum as a kind of AND or a maximum as a kind of OR, and then you can. This is some basic wave shaping, I would say.
Okay.
Yeah, you can do that.
Can you build an OR with an integrator and other stuff, or it's just a basic building block?
You would need a switch for that. You would need a VC switch, and then some tinkering around. But yes, it should be possible. at least, and what you call analog AND and OR, which I would not say these are not basic analog computing functions.
Okay.
Yeah, but if you need them, yes, you can patch them also. Yeah.
One more question I have is if you have to request for some missing piece of a module that currently doesn't exist, that you would like to have, or something that exists but you would like with some extra features, what will be?
Yeah, since I'm not into hardware design on my own, I have no electronic background and will never have. So I would love if one manufacturer would jump in and just build for me and some other interested customers, will just build like a larger module that would contain just one of each of these elements.
Okay.
Then you could combine them and have some.
Okay.
Yeah, that would be my dream module. I would be the first one to buy it.
Okay. Well, it's been a pleasure to talk. I have to add that Qetu is the only non-profit person in this whole affair, which is fine.
I'm not sure, but maybe.
And it's fantastic that you are doing this just for yourself, obviously, and for the rest of the people that you want to talk with. So we appreciate very much your time, everything that you are doing for coming to this, and also for having this conversation, Qetu.
Yeah.
Thank you very much.
It's my great pleasure. Okay.
Have a nice one. Bye-bye.
And see you. Bye.